Okay, so our first speaker today is from Mentor Graphics, Nigel Elliot, who's a design and verification technologist. He's going to be talking about making your ISO 26262 flow flawless, establishing confidence in verification tools. Nigel heads up a team of AEs focused on deploying Mentor's functional verification tools and methodologies. He's been with Mentor for 20 years and a number of technical roles, all relating to functional verification. Prior to joining Mentor, he worked as a digital design engineer doing ASIC and board design for telecom companies such as GPT and Motorola. At the moment, we can't see his slides. Okay, if you want to start, Nigel.
Okay, thank you, Mike. Morning, everybody. So yeah, this session is going to talk specifically around the automotive safety standard ISO 26262. This standard dictates that any tool that is involved in the design of automotive systems and the process relies on the output of those tools needs to be proven to be functionally correct and reliable. So this basically means any tool that could introduce a bug into a design, such as a software compiler or an RTL synthesis tool, or a tool that fails to detect a bug, such as verification tools, needs to be qualified in the automotive design process. The standard basically identifies the section for determining confidence in the tool and then relates that to. Basically, this is allows companies to limit their liability if in case anything subsequently goes wrong relating to their product. So why should you care about this? Because obviously it is required that you establish tool confidence and qualify as necessary. In particular for hardware development, everybody knows IC development processes are complex with many stages and many tools involved in those. So actually each tool involved in that process needs to be qualified or justified. And this can be a very large effort. So it needs to be planned for as part of an overall development process. Ultimately, this doesn't add any incremental value to your product. It's an overhead. It's something you have to do. So minimizing this overhead is key in terms of optimizing the overall design process. And what we find is various levels of expertise. So there are mature companies who have worked in automotive for decades and have a very well-established process. There are new entrants into automotive electronics. With the growth of electronic systems in cars, more and more companies are moving their products into automotive systems and so need to comply with ISO 26262. What we see is organizations are still learning how to do this, and the fact is that the standard itself is evolving. So although there is a version of the standard out there now, it is being updated and a new version will be coming in a couple of years' time. As I mentioned, the typical development for a semiconductor is complex. So all of the various steps and the various tools that support the overall design process, each one of those tools needs to be looked at and qualified on the confidence level for the use of that tool needs to be justified. So what do we mean when we talk about confidence level? So this is defined in the standard, and it basically, the confidence level is based on two things. Tool impact. This basically means, can the tool introduce a defect or fail to detect an error? If it can't introduce a defect or can't fail to detect an error, then it's TI1. If it can, then it will be TI2. The tool error detection, TD level, basically is a confidence level that a malfunction or erroneous output will be either prevented or detected. So you will have a high confidence level, a TD1, medium, and low TD3. And those together give you the tool confidence level, TCL 1, 2, and 3, which basically is the level of confidence that a software malfunction will not lead to a violation of a safety requirement. So if we look at those TCL levels, TCL 1 means that no formal tool qualification is required. So ideally, your tools will sit in a TCL 1 category, because this means there's, apart from doing the initial analysis to justify its TCL level, that's all you need to do. If it's a TCL 2 or TCL 3 confidence level, then some qualification of the tool will be required. So the challenges are defining the TCL level. So how do you define high, medium, and low for the TD level? There is no quantitative mechanism specified in the standard, and so TCL determination is currently quite subjective, and the details of how you define that level is left to you, but ultimately you need to have your decisions reviewed and accepted by the product safety manager. So actually there will be somebody who signs this off, and they will be carrying the responsibility if anything goes wrong. So there probably will be reasonably strict on this. Ultimately, most tool users don't want to have to go through this process, or may not even have the confidence that they have done the correct analysis and used the right approach. So what we've done at Mentor is to try and establish a fairly practical approach for establishing the TCL levels for our software. So what we've used is a fairly well understood, well-known approach used in the safety community for a number of decades of FMEA, failure mode and effect analysis. So it's an inductive reasoning approach, looking at single point of failures, and has been the core of safety engineering, say, since the last 50 years or so. It involves identifying the failure modes along with their causes and effects, and then documenting these and using this approach to then justify the TCL level for that piece of software. So a failure mode is any situation where a tool output can result in either creation or a missed design bug in the end product. Team of tool experts, so people who fully understand how the software works, evaluate the tool to determine what these possible failure modes might be, and then for each failure mode identify either internal or external means to detect or prevent the software failure introducing or failing to detect a design bug. Internal means looking at the tool development process and using some form of self-checking or restrictive use of the software. External may mean using other tools or use models, review processes, etc., to augment the capabilities of the software itself. So individual failure modes can be captured and analyzed for the severity, the occurrence, and the detection level. And these can be rated with a risk priority number, and multiplying these RPNs together gives you a level of high, medium, or low risk. So low risk is sort of less than 100, medium 100 to 1,000, high risk is 1,000 plus. So we've taken this approach with the tools used in the design process for automotives and started to do this analysis. Having got a confidence level, again, jumping back to the standard, if you are TCL1, then this, you don't need to worry about this, but if you are TCL2 or 3, the standard then says, okay, what do you do to qualify that software? What can you do? And it identifies 4 different approaches to qualify the use of a tool. And depending on the ACIL level, which is the automotive safety integrity level, with A is the lowest level and D being the highest level, the standard identifies which approaches are appropriate for which ACIL level. So generally for lower ACIL levels, the A-B, you can take approaches like increased confidence from use, which basically says I've used this software for so many years, I've never had a problem with it, and I can justify its use based on that. Up to the highest safety levels, where you need to take a more formalized evaluation of the tool, or actually take control and create a validation environment for that tool yourself. So I will just jump through these fairly quickly. The final level is that the tool is actually developed in accordance with the safety standard itself. And as I note here, this is very rare. I think generally you'll find that doesn't apply to mainstream EDA tools. So generally you will be looking at 1A, 1B, 1C in terms of approaches for tool qualification. So what you need to do for each tool used in your process is create a software tool criteria evaluation report, which basically describes the tool, how it will be used, the ACIL level of the project it will be used on, and then a justification of the TI, TD levels, and ultimately the TCL classification for that tool. Just back up here. And this is something that we're putting together for our tools, so we will be able to provide this level of information with our software, which basically can accelerate your process through these steps. If you do need to actually then do so, if your design does need TCL2 or TCL3 qualification, then you need to come up with a qualification plan which identifies tool requirements, a tool test suite, how you run the tests, and then documentation of the results of running that process. And this is an area where we will be happy to discuss with our customers how we can assist in setting up things like the tool test suite. So if there are tests that from our QA environment that we might be able to make available, things like that. Just a few little examples of going through the TCL evaluation. So let's look at a requirements management tool. If we look at its tool impact, the tool doesn't actually generate any code, so can't inject an error. The tool doesn't actually verify the design, so can't fail to detect an error. So generally you should be able to justify that this will be a TCL1 tool, and so no formal qualification should be required. If you look at an RTL simulator, then again, this doesn't actually create code, but it could fail to detect a design error. But based on the FMEA analysis, we basically can justify a TD1 tool level, and so again, TCL1. And to a certain extent, this is backed up by research. If we just look at things like the verification survey that the mentor sponsors fairly regularly, we never see RTL simulation listed as a reason for silicon respin. It's analog simulation might be a different beast, but RTL simulation generally, so when simulator bugs stop designs working, they don't make bad designs look like they're working. So just as a summary, tools are a vital part of any design process, and as for ISO 26262, are a key part of the overall safety program, and confidence has to be established. You have to take an approach for each tool used in the process, looking at whether it can result in a design bug, either being created or missed in verification. You may use internal and external means to prevent or detect these bugs. We've taken an FMEA RPN approach to allow you to have a quantified justification for TCL level. Ideally, you should be looking to get TCL1, because that basically, once you've justified the use of TCL1, that's it, that's all you need to do. If you have to do TCL2 or 3, then there is additional work required to be maintained. And as I say, we have identified that this is an area where we can help our users by providing packaged sets of information about how we develop and test our software that can assist with tool qualification if you can't fit into TCL 1 or 2, and actually the information to help you justify TCL 1. So just a quick, what are we doing? Mentor has identified or seen the growth in companies working or needing to work in an ISO 26262 flow. We've been investing both in technology that supports that process, but also expertise within our staff, and will continue to develop our capability in this space to support our customers. So that's everything I was going to cover this morning. I don't know whether we have any time for questions, but if we do, I'll be happy to take them.
Good example, Nigel, so I think there's a couple of minutes for questions. The first question is from Bristol. Anthony Wood, I'll just pass him the mic. Easier said than done.
Thanks. Yeah, I was just wondering what tools would normally require confidence levels 2 and 3?
I mean, it's a little bit vague here, and actually different safety managers may take different approaches. So that example I did for a requirements management tool, I know a particular safety manager who said no, because those requirements could be the safety requirements of the design, and if you didn't show that we hadn't implemented it, then that's almost like the worst case situation. So would actually want to have a TCL 2 or 3 level on that particular tool. So there will always be, I think there is at the moment there is a certain level of subjectiveness about this. I would suspect, as I mentioned, things like compilers and synthesis tools, where introducing bugs into designs. Now you may say, well, the justification for covering that is the verification process, and that's actually augmenting the implementation process. So it is, I think it's really driven by the ASIL level. I think for ASIL C and D, you generally are going to have qualification. And that the thing with EDA tools and just general design tools is that tools aren't generally inherently broken. They break on specific designs, and so validating that the tool doesn't break on your designs, on your type of designs, is probably makes sense.
Okay, thanks, Nigel. We'll just press the time now, and we've got one more question in Bristol. I think your answer will need to be a little bit shorter this time. It's saved from imagination.
No, in fact, I think you might have answered my question already, because my question was going to be tools. Is there kind of a one-off qualification, or per design you have to requalify the tool?
I think if your designs are similar, then you could justify one-off. If your designs are very different, I think you would need to qualify for each one.
Okay, and there's one very quick question for me. What about people writing internal scripts? A lot of companies have their own internal tools and internal scripts. Do they have to be qualified as well?
I guess again, you should take that same approach. Can they impact the? Can they inject an error, or can they cause the failure of detection? I guess if the answer is to either of those is yes, it can, then yes, I would say you'd have to.
Yeah. Okay, thanks, Nigel. It's a very good kick-off to the event today, and thank you for finishing on time, so thank you.
Thank you.